Hello friends, throughout this video we will learn the leveling concept in surveying in detail. If you like the video, please do share it and subscribe the channel. Leveling may be defined as the art of determining the elevations of given points above or below a datum line, or establishing given points of required heights above or below the datum line. As stated in the definition of leveling, the object of leveling are I. To determine the elevations of given points with respect to a datum. 2. To establish the points of required height above or below the datum line. Uses of leveling are I. To determine or to set the plinth level of a building. 2. To decide or set the road, railway, canal, or sewage line alignment. 3. To determine or to set various levels of dams, towers, etc. 4. To determine the capacity of a reservoir. Terms used in leveling. Level surface. A surface parallel to the mean spheroid of the Earth is called a level surface, and the line drawn on the level surface is known as a level line. Hence all points lying on a level surface are equidistant from the center of the Earth. Horizontal surface. A surface tangential to level surface at a given point is called horizontal surface at that point. Hence a horizontal line is at right angles to the plumb line at that point. Vertical line. A vertical line at a point is the line connecting the point to the center of the Earth. It is the plumb line at that point. Vertical and horizontal lines at a point are at right angles to each other. Datum. The level of a point or the surface with respect to which levels of other points or planes are calculated, is called a datum or datum surface. Mean sea level, MSL. MSL is the average height of the sea for all stages of the tides. At any particular place, MSL is established by finding the mean sea level, free of tides, after averaging tide heights over a long period of at least 19 years. In India, MSL used is that established at Karachi, presently, in Pakistan. In all important surveys this is used as datum. Reduced levels, RL. The level of a point taken as height above the datum surface is known as RL of that point. 7. Benchmarks. A benchmark is a relatively permanent reference point, the elevation of which is known, assumed or known. WRT. MSL. It is used as a starting point for leveling or as a point upon which to close for a check. The following are the different types of benchmarks used in surveying. A. GTS benchmarks. B. Permanent benchmarks. C. Arbitrary benchmarks. And D. Temporary benchmarks. A. GTS benchmark. The long form of GTS benchmark is Great Trigonometrical Survey Benchmark. These benchmarks are established by national agency. In India, the Department of Survey of India is entrusted with such works. GTS benchmarks are established all over the country with highest precision survey, the datum being mean sea level. A bronze plate provided on the top of a concrete pedestal with elevation engraved on it serves as benchmark. It is well protected with masonry structure built around it so that its position is not disturbed by animals or by any unauthorized person. The position of GTS benchmarks are shown in the topo sheets published. B. Permanent benchmark. These are the benchmarks established by state government agencies like PWD. They are established with reference to GTS benchmarks. They are usually on the corner of plinth of public buildings. C. Arbitrary benchmark. In many engineering projects, the difference in elevations of neighboring points is more important than their reduced level with respect to mean sea level. In such cases, a relatively permanent point, like plinth of a building or corner of a culvert, are taken as benchmarks, their level assumed arbitrarily, such as 100.0 m. 300.0 m, etc. D. Temporary benchmark. This type of benchmark is established at the end of the day's work, so that the next day work may be continued from that point. Such point should be on a permanent object so that next day it is easily identified. A level is an instrument giving horizontal line of sight and magnifying the reading at a far away distance. It consists of the following parts. I. A telescope to provide a line of sight. 2. A level tube to make the line of sight horizontal and 3. A leveling head to level the instrument. The following types of levels are available. I. Dumpy level. 2. Y. Or Y. Level. 3. Cook's reversible level. 4. Cushing's level. V. Tilting level and 6. Auto level. Dumpy level and its parts. Leveling staff. Terms used in direct method of leveling. The following terms are used in direct method of leveling. I. Plane of collimation. It is the reduced level of plane of sight with respect to the datum selected. It is also known as height of instrument. It should not be confused with the height of telescope from the ground where the instrument is set. 2. Backsight. BS. It is the sight taken on a level staff held on the point of known elevation with an intention of determining the plane of collimation. It is always the first reading after the instrument is set in a place. It is also known as plus sight, since this reading is to be added to RL of the point, benchmark or change point, to get plane of collimation. 3. Intermediate sight. IS sights taken on staff after backsight, first sight, and before the last sight, foresight, are known as intermediate sights. The intention of taking these readings is to find the reduced levels of the points where staff is held. These sights are known as minus sights since the IS reading is to be subtracted from plane of collimation to get RL of the point where staff is held. 4. Foresight. FS. This is the last reading taken from the instrument station before shifting it or just before ending the work. This is also a minus sight. V. Change point. CP. This is also known as turning point, TP. This is a point on which both foresights and backsights are taken. After taking foresight on this point, instrument is set at some other convenient point and backsight is taken on the staff held at the same point. The two readings help in establishing the new plane of collimation with respect to the earlier datum. Since there is time gap between taking the two sights on the change point, it is advisable to select change point on a well-defined point. Temporary adjustments of a level. The adjustments to be made at every setting of the instrument are called temporary adjustments. The following three adjustments are required for the instrument whenever set over a new point before taking a reading. I. Setting. 2. Leveling and 3. Focusing. 1. Setting. Tripod stand is set on the ground firmly so that its top is at a convenient height. Then the level is fixed on its top. By turning tripod legs radially or circumferentially, the instrument is approximately leveled. Some instruments are provided with a less sensitive circular bubble on trib ratch for this purpose. 2. Leveling, figures on next slide. The procedure of accurate leveling with 3 leveling screw is as given below. Loosen the clamp and turn the telescope until the bubble axis is parallel to the line joining any 2 screws REF Fig 15.5, A. Turn the 2 screws inward or outward equally and simultaneously till bubble is centered. Turn the telescope by 90 degrees so that it lies over the 3rd screw Fig 15.4, B, and level the instrument by operating the 3rd screw. Turn back the telescope to its original position Fig 15.5, A, and check the bubble. Repeat steps, 2, 2, 4, till bubble is centered for both positions of the telescope. Rotate the instrument by 180 degrees. Check the leveling. 3. Focusing. Focusing is necessary to eliminate parallax while taking reading on the staff. The following two steps are required in focusing. Focusing the eyepiece. For this, hold a sheet of white paper in front of telescope and rotate eyepiece in or out till the crosshairs are seen sharp and distinct. 2. Focusing the objective. For this, telescope is directed towards the staff and the focusing screw is turned till the reading appears clear and sharp. Types of direct leveling. The following are the different types of direct leveling. Simple leveling. 2. Differential leveling. 3. Fly leveling. 4. Profile leveling. V. Cross-sectioning and 6. Reciprocal leveling. Simple leveling. It is the method used for finding difference between the levels of two nearby points. 2. Differential leveling. If the distance between 2 points A and B is large, it may not be possible to take the readings on A and B from a single setting. In such situation, differential leveling is used. In differential leveling, the instrument is set at more than one position, each shifting facilitated by a change point. HI method with example. Height of instrument method, also called collimation plane method. In this method, height of instrument, HI, is calculated for each setting of the instrument by adding the backside, BS, to the elevation of BM. Height of instrument, HI, equals RL of the plane of collimation. Equals RL of B.M plus BS on BM. Now see previous example. The red color shows the given data and black color shows RL of points which we need to calculate. The procedure is as below. Now see previous example. The red color shows the given data and black color shows RL of points which we need to calculate. The procedure is as below. Arithmetic check, for HI method. Rise and fall method with example. In this method we will first calculate difference between two consecutive stations and do the procedure as below. From BM to station P1 calculate difference in reading equals BS on BM, IS on station P1. If answer comes any positive value then write only value. If front of station P1 in rise column and answer comes negative value then write in front of station P1 in fall column. From station P1 to station P2 calculate difference in reading equals IS on station P1. IS on station P2, if answer comes any positive value then write only value. If front of station P2 in rise column and answer comes negative value then write in front of station P2 in fall column. From station P2 to station P3 calculate difference in reading equals IS on station P2. IS on station P3, if answer comes any positive value then write only value. If front of station P3 in rise column and answer comes negative value then write in front of station P3 in fall column. From station P3 to station P4 calculate difference in reading equals IS on station P3. IS on station P4, if answer comes any positive value then write only value. If front of station P4 in rise column and answer comes negative value then write in front of station P4 in fall column. From station P4 to station CP1 calculate difference in reading equals IS on station P4. FS on station CP1, if answer comes any positive value then write only value. If front of station CP1 in rise column and answer comes negative value then write in front of station CP1 in fall column. From station CP1 to station P5 calculate difference in reading equals BS on station CP1. IS on station P5, if answer comes any positive value then write only value. If front of station P5 in rise column and answer comes negative value then write in front of station P5 in fall column. From station P5 to station P6 calculate difference in reading equals IS on station P5. IS on station P6, If answer comes any positive value, then write only value if front of station P6 in rise column, and answer comes negative value, then write in front of station P6 in fall column. From station P6 to station P7, calculate difference in reading equals IS on station P6. FS on station P7. If answer comes any positive value, then write only value if front of station P7 in rise column, and answer comes negative value, then write in front of station P7 in fall column. Then to calculate RL of each station, use formula as RL of any station equals RL of previous station, value in fall column in front of that station. Or RL of any station equals RL of previous station plus value in rise column in front of that station. Arithmetic check, for rise and fall method. Sigma BS, sigma FS equals RL of last point, RL of first point equals sigma rise, sigma fall. 3. Fly leveling. If the work site is away from the benchmark, surveyor starts the work with the backside on the benchmark by setting instrument at a convenient point. Then he proceeds towards the site by taking foresights and backsights on a number of change points till he establishes a temporary benchmark in the site. Rest of the leveling work is carried out in the site. At the end of the work again, leveling is carried out by taking a set of convenient change points till the bench work is reached. This type of leveling, in which only backsight and foresights are taken, is called fly leveling, the purpose being to connect a benchmark with a temporary benchmark or vice versa. Thus the difference between fly leveling and differential leveling is only in the purpose of leveling. 4. Profile leveling. This type of leveling is known as longitudinal sectioning. In highway, railway, canal, or sewage line projects, profile of the ground along selected routes are required. In such cases, along the route, at regular interval readings are taken and RL of various points are found. Then the section of the route is drawn to get the profile. 5. Cross-sectioning. In many engineering projects, not only longitudinal profile but also the profile of cross-sections at regular intervals are required. These profiles help in calculating the earthworks involved in the projects. Cross-sectional length depends upon the nature of the project. Types of errors in leveling. There are following types of errors in leveling. 1. Instrumental errors. 2. Collimation error. 3. ERROR due to curvature and refraction. 4. Other errors. Instrumental error and correction. Collimation error. Correction, check before use and equalize sites. Under sensitive bubble. Errors in staff graduation. Correction, check. Loose tripod head. Telescope not parallel to bubble tube. Correction, permanent adjustment. Telescope not at right angles to the vertical axis. Correction, permanent adjustment. 2. Error of collimation. Collimation error occurs when the collimation axis is not truly horizontal when the instrument is level. The effect is illustrated in the sketch below, where the collimation axis is tilted with respect to the horizontal by an angle A. Curvature of the Earth. The Earth appears to fall away with distance. The curved shape of the Earth means that the level surface through the telescope will depart from the horizontal plane through the telescope as the line of sight proceeds to the horizon. This effect makes actual level rod readings too large by. Effects of curvature are: rod reading is too high. Error increases exponentially with distance. How to eliminate error due to curvature and refraction. Proper field procedures, taking shorter shots and balancing shots, can practically reduce errors. Wherever possible, staff readings should be kept at least 0.5 m above the ground. Using short observation distances, 25 m, equalized for backsight and foresight. Air below is denser than air above. Air below is denser than air above, line of sight is bent downward, which negates earth curvature error by 14%. Simultaneous reciprocal trigonometrical heightening. Observations made at each station at exactly the same time, cancels the effects of curvature and refraction. Thank you for watching the video. If you like it, please do share it and subscribe the channel.